Yeah, hello, welcome. So in the background of that slide, that's our lab. That's the Q department. We call it Reality Lab. We call it Reality Lab because, there's so many technologies that somehow add the word reality to it that we are all interacting with. So reality is the one thing we all meet. So this talk is about spatial context. And in this talk, I want to figure out if I can leave you with 3 takeaways. So the first takeaway is spatial context is the killer application. The second one is AR is now an architectural scale. And the third one is we have a spatial toolbox for you. So if any of these takeaways somehow resonate with you, come to me later after this talk or meet us in Seaport, or here's 2 colleagues of my team. You can get in touch with them. I really want to see that any of these 3 takeaways resonate with you. So let's start with the first one. For the last year or so, I evaluate and look at many augmented reality applications. And I try to formalize why one idea is good, why another is not so good. What is it that really makes augmented reality tick? And more I start asking this question, do you have a spatial problem? And it is really hard to see if I have a spatial problem when I look at a single object. And so, for example, if I just have something like a radio, a single object, single user interface, a single user, single application, it's really hard to really understand what is the real key value in augmented reality. But the interesting thing is when you start looking into bigger scales, when you start going out of that micro scale of the single application, single object, and you actually go into a bigger scale, and you start looking into the problems of spatial context, then you understand, wow, there's actually something in here in augmented reality that's really the key killer application. So for example, here you have something that we currently would explore with a 2D interface. So you can explore in an app all the features of cereal boxes, for example. Or you put spatial context to it, and suddenly you can just browse through a grocery store, and you can see all the products that you maybe have an allergy and you cannot consume it. It allows you so much faster to engage with information because that information is now put in spatial context. Another example. On the left side, you see how we currently program robotics, like big robotic arms in factories. It's a 2D interface that you need to move X, Y, Z axis, and it requires expertise to really master that kind of interface. On the right side, you see us putting spatial context to that interface. And suddenly it becomes child play to really program an industrial robot. So you see how the operator of that application here has drawn a spatial path that the robot now will follow. And it's easy to operate the robot with that. Another example, manuals, user manuals. You have these 2D user manuals, and you look maybe at your furniture in parts on the right side, and then you look at your manual on the left, and you're like, oh my God, how do I put this together? That's a classical example. You have 2D user interfaces for manuals, but you have a spatial contextual problem. With augmented reality, you can easily, going back to that slide and playing it double, you can easily look at the task and perform a manual operation. The next one is interesting. It's not a 2D interface, but it's a voice interface. How often do you find yourself in a situation that you have somebody on the other side of the phone and you try to explain them something that has spatial context, but all you have is a voice to explain it? And so you sit there, both of you have some idea in your mind how the world could look like on the other side, and you talk and talk and try to explain it. It's a problem. You add spatial context to it, and it allows you to have a much better conversation. So I'm going to play this video. It has sound, so I'm going to be quiet.
This is Vuforia Chalk, an easy-to-use, powerful support tool that allows your workforce to collaborate in real time, anywhere. Chalk enables your workforce to connect for support or training. First, employees can share a live view of their workspace with an expert or coworker.
The waste valve here. Now that that's closed, you can turn on your surface wash valve, which is here.
Okay, got it.
Both people can draw on the world and work together as if they are together. And thanks to Vuforia Augmented Reality technology, your annotations stick exactly where they're drawn, even when you move around as you work. In fact, you can pause the live view to draw easy-to-follow, multi-step instructions. With Chalk, simple instructions help you solve complex problems quickly and effectively.
Another example where spatial context is really the killer application for augmented reality. And so you can ask yourself, like all of these AR applications that you might work on, is there a spatial context involved in here? And you will find that the one ideas that take a problem that has spatial context and is currently removed on a 2D interface or so on, you add augmented reality to it, and you will have a really good problem solution. So this is one of the first takeaways. There's the reason why this is a killer application might lie in the way that our brain works. So we all have a superpower that allows us to understand spatial context. It's an active spatial learning part in our brain. So when we look at smartphones or when we look at a computer, there's no spatial context. We use regions of our brain that are responsible for object recognition, but we don't use that whole superpower that we have in there that allows us to walk through the world day by day. There's some research behind that says, spatial knowledge allows users to focus cognitive resources on tasks rather interfaces. This is something that's out there, that's research, it's really profound. And it's a killer application for augmented reality. So it's really hard to see this killer application for as long as we look at a single application, a single user, a single object. If we just have this one thing in front of us, maybe it is intriguing, it is interesting. There's maybe something in there that triggers our spatial contextual learning here. But it really crystallizes when we put it into a bigger scale, when we scale it into these examples that I showed you. So that brings me to the next takeaway. We're now in a really, really interesting moment for augmented reality. This is, from my perspective, one of the most exciting times. It's something that I was looking forward for the last 6-7 years, ever since I work in augmented reality. Because we're now no longer look at these individual objects that we create experiences around. We now have actually the opportunity to go into architectural scale. We are now able to look into bigger scales and not be that product designer that looks at a single object, but actually be that architect that defines how people walk through spaces, navigating them around, giving them information about what to do in these spaces, and really, really trigger that spatial learning. So from my perspective, architectural scale AR is something that really scales every aspect of what we do. It says augmented reality for multiple users that can co-locate and interact together on the same content. Multiple applications that really can populate the world around you. Multiple objects, like all the things around you that we can interact with. And multiple spaces, so you can walk from one space into another and you always contextualize, you always have the spatial context around you. That's really the foundation for architectural scale AR, and that really triggers all of these benefits of spatial context. So PTC has some interesting work in here. So you're looking currently on a massive scan of a big office building. And we can seamlessly fly around in this building. And we have scanned this entire space. And we can put ourselves into that space in every position in that space. For example, in this demo, you see a person that can just enter a space and add content into a space. You see on the right side, on the lower right side, you see a map. You see that that person is actually localized in one aspect of that big space. The person can walk around at every given moment. It's tracked. It knows where the person is. This is multi-user, so multiple users can localize themselves in the same space, can be in the same moment. Another example from an architectural perspective, here we have this, this little drone, and that drone has a few options where you can go. So you choose, like, let's show me the kitchen. So it will show you a pathway where to go to the kitchen. So these are now ideas that you can think about once you have that bigger scale of augmented reality. So PTC has this amazing platform, our framework for augmented reality, the Varia engine. And you might all know Varia engine. And we have these amazing image targets, multi-targets, objects targets, and so on. They allow you to identify objects or put content on objects. There are device trackers and ground plane to explore spaces or go into bigger spaces. And now there's this new kid on the block here, that little thing. It's called ARIA target. And that is really the technology that enabled those 3 videos that I just showed. And ARIA target works together with all of these other targets types. So you can explore now spaces. You can explore objects in these spaces. And because of the ARIA targets, multiple users can explore the same spaces together. That's a big deal because, from my perspective, ARIA target is the key component for spatial computing. And Engine is the world's mostly wide deployed AR solution. So us rolling this technology out there really puts augmented reality on an entire next level. And this is really something I was working on technology for a long time, and I'm like, man, if this would be possible one day, that would be really amazing. So I think that's pretty cool. I was not paid for saying that, but I'm really, really amazed about it. So the last takeaway, with all of these other 2 things that I talked about, is something that we call, that is a spatial toolbox for you. So we're working on some technology for quite some time now where really all of that architectural scale augmented reality, we want to enable that for you, and we want to give you something into your hand so that you are able to explore that kind of technology. So that you can put information in space and do spatial computing, and that you can co-locate yourself with others. And all of these things that I just talked about, that they are not just future fantasies, but actually you can do these things. So I want to show you this tool. It's a very simple tool. So here you have that tool, you have that little pocket on the side, and I can just browse through a couple of applications, spatial applications. And let's just take one and build a little hello world. That's a slider. Take another one. That's a little graph that can help you to analyze things. There's this little button. That's a programming button. And drawing a line from A to B creates a little hello world. Very simple. I can tap on every element in this world. I can move it around. I can scale it. I can also define how far away I can see it. So by me walking backwards, I can define how far away in space I actually can see something. It's a very simple little tool. But this tool is deeply rooted in the world around us and in spatial context. So I can, for example, approach this machine here, and I can immediately see the program of this machine. I see how these buttons are connected to that logic and to driving a conveyor belt, and then these red and green lights. And that drives this machine. That's not just a representation. This tool is so rooted in the world that this is actually the way that this machine was programmed. So you see, I interrupt this program, stop working, I reconnect it, and it works again. So I'm looking at a single object right now, but again, the multiple objects spaces, multiple users. So another thing that I can do, we have these little logic nodes. You can put them into the world, spatial programming. It allows me to drag and drop little logic blocks in there and reprogram the world around me. Okay, single object, single machine. But I can just walk around and look at multiple applications, multiple objects. And for example, another table here that has another program. This is a scale. I can push that scale down. You see that limiter application and a little button. There's another program in here. And now I can do an interesting thing. I can take that one program, connect it to another program, and form units of objects, units of things in the world around me. So I can program the world around me through augmented reality, through spatial computing. At any given moment, I can make adjustments, readjust it. So this is a starting point. This is an example of what you can do with this. Any element in here is programmable. Any element, in fact, that you currently see is built with HTML. So you can just build something as you would build a web page, throw it into the system, and it will work in this whole environment. If you want to go there and you need 3D graphics, this whole thing is WebGL compatible, so whatever you want to do, you can do it. Another cool feature is you can just instantly build HMIs with applications that are HTML-based, and you can take them out of the screen and drop them somewhere in the world. And you can do the same thing backward as well. You can take any applications that is in the world and put it back on a screen. So you can connect these two spaces seamlessly, the screen space and the augmented reality space. The next one is a little bit more complicated example, and it shows really a whole depth of what this tool is possible. And I'm gonna let Anna speak here because she did the voiceover, so I'm just gonna be quiet.
This is Frida, an MIR 100 automated guided vehicle with a scale unit on top. And this is Anna, our robot operator. Using Toolbox, Anna sets the weight she needs on Frida. Toolbox is a platform to program machines in augmented reality using JavaScript and HTML language. Using nodes with attached logic, anyone can connect and program the behavior of any piece of hardware in AR. Anna can connect the scale to a feeder machine. The AR logic nodes allow her to program the machine to receive a target weight from the feeder before continuing its path. Anna can now design a path for Frida to follow. The system is spatially aware. It tracks the environment and knows the location of the machines in real time as they move. Anna can create checkpoints on the floor for the robot to follow. She can set the rotation of the AGV at each checkpoint and visualize how it will fit into the space in advance. Both systems can be programmed together. When the feeder detects that Frida is on the last checkpoint and the weight hasn't reached the set target weight, it will activate the conveyor belt. Anna also connects the physical button to the first checkpoint in order to activate the motion of Frida. When she presses the button, the first checkpoint activates and Frida starts moving towards it. Frida follows the set path. By performing spatial tracking with a smartphone, we are able to synchronize the environment recognized by the phone and the AGV. The user can control the motion of the AGV without any further technical requirements than a mobile phone. We envision this technology as a usable system for the creation and visualization of manifold AGV operations, while maintaining a low entry barrier to complex spatial hardware programming.
So this is another aspect that you can do with this system. You can program robots. You can bring logic into the world and coordinate all of these things together. Multiple objects, multiple users, multiple applications. we put a really beautiful, or let's say, we took a lot of time to think about the user interface that you saw in these in all of these videos. And we worked with a very gifted fictional user interface designer, Andrea Braga, together to really figure out user interfaces that work in every kind of environment, in dark environments and bright environments, visual to the eye, so you can easily see them and interact with them. And they're distinct from the real reality around us. So these are some elements. Here are some other elements for robotic use, and so on. We're evolving applications and features of this tool. And the name of this tool is simple: Toolbox, ARIA Toolbox. It's a toolbox for you to explore spatial computing and to explore what it means to put augmented reality into architectural scale. And we want to give this into your hand in a way that you can really explore it and research and innovate with this. So we're publishing this whole toolbox on GitHub, and we put it under MPL 2.0 so that you're able to join us and to collaborate with us. And we want to learn from you what is possible with this tool, and I hope you can learn from us what is possible with this tool. And together we can really explore this architectural scale augmented reality and spatial computing fully. So our goal is to put this out in April. That's not an optimistic goal. This is by this point a pessimistic goal. So we're gonna get there. And that's the little announcement. And please. So find us later in Seaport. All of these demos that you just saw, we're going to have them there. You can look at them, explore them, and ask us questions. And stay connected. Keep that date in your mind, and check out what we're going to publish at that time. So I want to close this whole talk with two more experiments that we actually use this toolbox for in our lab, and that show you a little bit more of the potential of this toolbox. So the first one has to do with spatial context again. In a factory, there are these moments when you have to repair a machine, and you have to perform a specific procedure called logout-tagout in order to de-energize the machine so that you don't kill yourself when you repair the machine. Currently, you would create that logout-tagout manual on a piece of paper and tell a person how to do that through that paper. And if there's enough spatial context in that manual, like you have to walk around, push different buttons, it can become complicated to really get all of these things right. So here we built a little demo example in that toolbox. And the operator, Ben in this case, who worked on all of that and was actually, at this point, the core developer of this whole toolbox, he built this little example here, and it shows you how something that's on the left side on this paper, he can really easily create within that toolbox. So it's not just an experimental thing. It's like you can alter in it, you can publish, you can do all kinds of things. So once you've done all of these procedures, another person can say, okay, I want to execute that manual. I want to understand what to do. So it guides you spatially where you have to go. It provides you contextual information, a little video, what's happening at that de-energizing point. And it tells you all the relevant information that you need in order to perform this. So what a big improvement from a piece of paper where you need to question and kind of do that hunt and figure out where to actually de-energize something, to a tool that really guides you exactly where you have to go, shows you what you've done, show you how you do it. Okay, small experiment. Another experiment I want to show you has to do with, how we can explain it, a remote operator. Everything I showed you so far has to do with being at a location, being in the space. But now that we have spatial context, we can remove us physically from the space, but probably still be there. So we start another example, because this is a multi-user, multi-object, multi-application scenario here. So why do we have to be physically there? We can remove us from that scene. So you see here right now something we call a ground truth of our reality lab. It's a 3D model, and in that 3D model, we have installed a couple of Kinect cameras. And these Kinect cameras illuminate now this scene with real-time spatial context. And so in this video, you see that what these cameras see, and they're all calibrated together so that I can actually get a nice 3D representation in real time from that. And so now what I can do, I can look at the scene and see how people walk around in it, see what's going on in that space. I can put myself in a bird's eye perspective, or I can start flying closer to this scene, co-locate myself with my colleagues, see what they're doing. And you also can see that actually this entire toolbox is enabled in that spatial contextual, virtual, augmented, whatever we can call this, reality. And everything is real-time and collaborative through the internet. That's happening in a web browser. And so Ben here right now is looking at this machine. He sees through his phone what I do. I just programmed the demo that I earlier showed you. And I can also ask him to place maybe a graph in that scene, and at any given moment I see what he's doing. He wired up that graph to his sensors, and now we can analyze that machine and learn about this machine. So this is something that really works. Like, multiple people could now walk around with phones in this space, place applications in the space. I could take a bird's eye perspective, see where things are going. For us, this is right now a playground in which we explore further. And I hope I can show you more of these things further down the road. But I leave it with that. So that's a talk. Thank you very much.